All right, we're live. This is Toby, and we're continuing this series where we walk through the LLVM, my first language front end tutorial. We're in the later part of chapter 2. Hopefully, this is gonna be the episode that finishes chapter 2. Chapter 2 has been a lengthy chapter. So in the last episode we finished, although we haven't tested the code, but we finished writing the code to parse binary operations. And we did it in a way that handles operator precedence. And operator precedence is done using this technique, which I believe is called the shunting yard algorithm, where we assign a number to represent the precedence of each operator. And then there's this clever logic during the parsing that makes use of that information to make the tree shift correctly to represent the correct precedence. This time we're gonna do the section called parse the rest, and let's just start by copying the example code line by line. This one is gonna parse prototype, and what they mean by prototype in their language, it is not like a JavaScript prototype, but it's the prototype of a function, which means the function signature. So we're gonna parse the function signature, is what that means. Which I think it looks like, foo bar nm. If these are the parameter list, and this is the function name, and this whole thing, that's what we're parsing. There's going to be a identifier token, there's going to be a left paren as a token, there's going to be another identifier token, or for each of the parameter things in the parameter list, it's going to be an identifier token. The comma is going to be its own token. This is going to be an identifier, and this is going to be a closing paren is how it's going to go down, I think. And this function is going to return a unique pointer to a proto-AST. Okay, so it's saying if current token is not a token identifier, we're like throwing an error, basically. Not use throwing of errors. So this is the place where it actually uses the log error p function. I'm still not sure why that's needed, honestly. So it can return the same type. That's a waste. I don't like this way of doing it, but I won't complain too much. I mean, whoever wrote this tutorial, thank you so much. I think I would have a much harder time learning LLVM. So I will try my best not to criticize. Okay, so we're basically expecting the first token to be an identifier. If it's not, we're throwing an error, or we're erroring out. And because we already verified that the current token is an identifier, we expect the name of the identifier to be in identifier string. We're gonna stick it in this function name variable, and this get next token eats the identifier. Okay, and now we're expecting, after eating the identifier token, that the next token after that is going to be an open paren. So I'll just copy this bit. So if it's not an open paren, again, we're erroring out right away. Now we're going to read the list of argument names. I'm going to type this out and then explain it line by line. first we're gonna instantiate a vector of strings, which are gonna be the argument names, and then we're gonna do a while loop. It's saying while, let me see. So this is not comma delimited, actually. Interesting. It's not comma delimited. That means my picture is like bar, open paren, and no comma m. It should look like that. That's fine. So I'll just follow what it does. So while get next token is identifier, then we're gonna push this token, the identifier string, to the back of this vector. If current token is not a closing paren, then there be problems. Okay, because after this argument list, we're expecting a closing paren. Oh, this should be our names, and then but if it is, then we're gonna consume that token. And then if everything is successful, we're gonna return a unique pointer using make unique. It's gonna be a unique pointer to a proto AST with the fun name, and we're gonna need to use standard move to move the arg names. I think. Okay. Interestingly, it's not a unique pointer here. Not sure why, but it is a unique pointer here. Okay. So that parses the prototype of the function, and now let's parse the definition, I believe, of a function. So we're assuming that the current token is the def token, so we're eating the def token. If we did not successfully parse a prototype of the function, we're gonna return the null pointer to signal that stuff failed. Now I'm gonna do this in 2 separate lines because that's my style. We're gonna parse an expression next, and if that worked, we're gonna I think the function probably is gonna be the body of the function, I believe. Again, we're gonna use make unique to new up, so to speak, a new function AST. We'll put the proto in there and also the expression in there as the body of the function. I would have called that body, but okay. Whoops, I think I just reverted a page. Okay, so and if that didn't work, we're returning a null pointer. Okay, so that is, this parses a function definition, and then we're gonna write the code to parse an extern. Extern is like there's a function that's just defined externally, I think, and then you're just gonna write like extern foobar, something like this, and you're saying, oh, somebody defined the foobar function, not me, but I know someone did, So I want to call this function. Just let me call the function. That's what it. Okay. It already assumes that the extern token is the current token again in the same style, and it's gonna. Oh, I see. Because this is gonna be a function prototype, so it will look actually more like extern foobar and an m and an n. So yeah, okay. The parse the top level expression, and I think that's the last parse function we have to write. Okay. I'll do that in 2 separate lines, as you don't have to do. You can do the tutorial code as you want. Okay. So this is saying what is the top level expression? Oh, I misspelled unique pointer. Pointer is spelled PTR, obviously. Parse, no space, top level expression. So what is a top level expression? Well, we're just gonna parse an expression. Oh, I see. We're gonna wrap it inside a top level function. Like there's an implicit top level function that's unnamed. Wow. And an empty vector for its arguments. Alright, I didn't see that coming, but that's cool. Do we need to move it? No. Alright, like that. Yeah. And then we're gonna make another unique. And standard move E. And then I guess if that didn't work, we're returning a null pointer. Alright, now we're finally ready to test this code. That's what the driver is about. So let me write that out. So this is like while true, basically. While true. Oh, this is a prompt. This is like a REPL. So you can type in the code as you go. I guess if you get a NF file, it just returns out of this main loop function. Oh, semicolons will get ignored. What? Semicolons get ignored. If it's a def, then we're gonna handle definition. If it's a, what does handle mean? Did you mean parse? Handle top level expression. Where are these handle blah 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 functions? Do you even have these functions? Oh, I see. I see. Okay. These handle definition. Why does he have these functions now? Parse a definition and it'll just say I parse the definition. But if it didn't work, skip the token for error recovery. Okay, fine. I will copy this code. And then, okay. I'll copy this code that does this. This is like a REPL. And then I will, I'm not gonna do this precedence dictionary thing because I decided to do it using switch statements, I think, if I remember correctly. And we return 0. That's not really necessary, I think. Run the interpreter loop. Okay, let's cross our fingers and hope this works. I guess for now we don't actually get to see the AST structure that we generated. All it's gonna say is tell us that it successfully parsed something. Let's compile this code, which I had aligned to compile it previously. I will reuse it. So gcc mylang.cc-o mylang.bin. Well, that did not work. We have some errors in the program. Let's fix them. 6 errors. Oh, I need another colon here. I'll try again. Oh, shoot. What's going on? Space is required between consecutive right angle brackets. Oh, seriously? So line 114, like I need space between those things. Oh, that is true. So now it's complaining about that in here. Okay. Alright, let's go to the next one. 152. Alright, let me recompile. That is a lot of errors. 20 errors and 7 warnings. Okay, I'm gonna use less to see the top of this error list. Oh, that didn't work out. Use more. No, I might need to do like type number 2. Oh, I don't actually know how to do this. I don't know how to use less with standard error, I think. Alright, let me just try again. Make unique. No member called make unique in namespace standard. Probably I need to, oh, I need memory is what it is. That's what I heard. I had to include memory in order to use the unique pointer thing. The smart pointers is in memory library. Still did not work. Not sure why. There's still a space needed. And also, oof. Unused value. Bin up is unused. Okay, let's go to the top of these errors. Return null pointer. 154. Why don't you want me to return a null pointer? No viable constructor. Returning object of type unique pointer of expr AST. So this log error function, let me see. It returns a null pointer and it's complaining to me about that. It says no viable constructor returning object of type standard unique pointer of expr AST. Candidate constructor, not viable. Expects an L value for first argument. So I think it's saying that it's not allowed to, we're not allowed to return a null pointer. Isn't it saying that? I'm just gonna make this be a void method, and I'm not even gonna bother having this log error p. I think we just use this one log error function, and if we need to return something, I'll use a separate statement to return the null pointer. Not sure whether why I am deviating from the tutorial. I didn't add a block to this. I should have done that. I'm not even gonna have the log error p function anymore. Just always gonna use the error function. I think that's all of them there. Okay, let me try again. 6 warnings and 20 errors. We still have 20 errors. Jeez. Auto type specifier is a C++ 11 extension. Yes, give that to me, please. I want the C++ 11 extension, please. So I think that means I just have to, in my command, I stick this in there, right? No? Alright. I've done this before. I know this is pretty easy to do, but I just need to Google it. How do you do this? Oh, you do that. Standard equals C++ 11. This is for Clang. I think I am actually using Clang. I think I'm already using Clang, but I don't know, you might not be. 4 warnings and 19 errors this time. Alright. Okay, now we have no member named make unique. 157. If it's not called make unique, then what is it called? It is in the memory module, and I did include the memory module. Is it? Is standard make unique? Yeah, standard make unique. I roll it like that every single time. Number expr AST does not. Use of undeclared identifier parse express. I might need to forward declare that guy. So let me try that. Now, while I can copy the code from the tutorial, I kind of like figuring out for myself, because I feel like then I can learn a lot more about the language that way. However, we could use the source code as a kind of a quick test. So I'm gonna grab this source. Oh. This uses the LLVM libraries. Does it actually use the LLVM libraries? It uses some STL extras. Really? We might have to compile it like this. Only 2 errors generated now. Use of undeclared identifier parse bin up right hand side. Wow, that got rid of that many things. 248. So you're saying this is, I need to forward declare this. So in C and C++, if you want to use a function that has not been defined yet, you have to forward declare the function, like declare the function signature of the function before, whereas in JavaScript that's not needed because of hoisting, but not so in C and C++. Only 1 error generated now. Now it's saying, oh sorry, that's interesting. This, I'm using Clang, but I think G++ is the same thing, yeah? Okay, so this error is something about, it's a call to implicitly deleted copy constructor of this unique pointer. In algorithm, in this pushback here, 194. I got this arc, which is a unique pointer to an expression AST. We're using pushback to push it to this arcs list and implicitly delete. Copy constructor is implicitly deleted because unique pointer of an expression AST has a unique what? I don't really understand what it is saying to me. I guess I could look at their code. Okay, hold and see if it works. Their code. Change this to their code. Whoa. Disable ABI brick checks. Undefined symbols. linker command failed with exit code 1. LLVM disable ABI break checks. Where is my LLVM config? That's there. That's where I put it. By the way, before I started this, I downloaded the pre-built version of LLVM from this page. And I went down and got the newest one, which was version 10. Came in March of this year. I got the OS 10 one. I extracted it, put it in LLVM inside my home directory, and inside of it there's this bin directory. I have never seen this error before, so I guess the best I can do is Google for I do find something related to this kaleidoscope tutorial. You'll need to link